Hello class, our topic today is going to be measurement. Now, physics is actually a branch of science that deals with the physical properties of nature, matter and energy. So that means physics actually has to do with a lot of measurement. Now, measurement is a very important aspect of physics. No fact in science is accepted unless it's exactly measured and quantified. Now, since physics needs exact measurement, it requires two things. The first one is the number or quantity, and the second one is the unit. Now, let's take an example. Now, if I want to measure a length, maybe the length of a book. Now, the length is the quantity, and then since length is in meters, that's the system international unit of length is meters. Now, meters is the unit, while length is the quantity. So it requires two things: the number or quantity, and then the unit. Now, for a unit to actually be standard, it must be one. It must be easily defined. That means it must not be ambiguous. 2. It must not vary with time and place. 3. It must be reproducible. And 4. It must be easily divided or multiplied. Now, we actually have three important physical quantities. The first one is length, the second one is mass, and the third one is time. We have different instruments for measuring physical quantities. Now, let's look at the two main types of quantities and units we have in physics. Now, the first one is fundamental quantities and units, and the second one is derived quantities and units. Now, what are fundamental quantities? Now, fundamental quantities are those basic quantities which are independent of others. That means they cannot be defined in terms of others or derived from others. And fundamental units are those basic units upon which other units depend on. They are the units of fundamental quantities. Now, let's look at fundamental quantities and units. The first quantity is length, and the unit is meters. The abbreviation is M. The second one is mass. The unit is kilogram, and the abbreviation is kg. The third one is time. The unit is second, and the abbreviation is S. The fourth one is electric current. The unit is ampere, and the abbreviation is A. We have temperature. The unit is Kelvin, and the abbreviation is K. We have some other quantities, fundamental quantities and units. Now, let's move to derived quantities and units. Now, derived quantities and units are those quantities and units that are obtained by simple combination of fundamental quantities and units. They are obtained by simple combination of fundamental quantities and units. We have them as follows. Now, the first one is area. Now, the derivation. Now, area means it's actually gotten when you multiply length and breadth. So that means since the unit of length is meters and that of breadth is also meters, it means that the unit will be meter squared. Now, the second one is volume. Now, volume is length times breadth times height. Now, since length is in meters, breadth is also in meters, and height is in meters, so meter times meter will give us meter cubed. So the unit of volume is meter cubed. Now, let's look at the third one, density. Density is defined as mass per unit volume. Now, since mass is kilogram and volume is meter cubed, that means the unit of density will be kilogram per meter cubed. Now, let's go to the fourth one, density. Now, velocity. Now, velocity is actually defined as displacement over time. Now, since displacement is length, which is in meters, and then time is seconds, So which is meter over second. The unit will be meter per second. Let's move to acceleration. Acceleration is velocity over time. Since velocity is meter per second, so it will be meter per second over second, which will give us meter per second squared. Now from there we'll move to the next one, which is force. Force is actually defined as mass times acceleration. The unit of force is Newton. We move to the next one, which is work or energy. Now work or energy is defined as force in a given distance. That is force times distance. Now since force, the SI unit of force is Newton, and that of distance is length, which is in meters. So it means that the unit of work or energy will be Newton meter, which is also joule. Now we move to the next one, which is power. Power is actually defined as work over time. Now since we've gotten work to be Newton meter and time is seconds, so it means that it will be Newton meter per second. Or power can also be defined as watt. Now the next one is momentum. Momentum is defined as mass times velocity. Now since mass is kilogram and velocity is meter per second, so it means that the unit of momentum will be kilogram meter per second. Okay. Now we have other derived quantities and units. We have so many of them. They are actually gotten when you combine fundamental quantities and units. Simple combination of fundamental quantities and units gives us derived quantities. Now, is there any question so far? Do you have questions? Alright. No questions? Okay. Alright. And then that'll be all for today. Thank you.